Hello, I'm Mr. Hotelling, and welcome to this installment of Numbers in Science. In this installment, we're going to look at calculations, in particular, addition and subtraction. And this is the fourth source of numbers. We began a quest to understand where numbers come from in science, that we use them, and the fourth source of those numbers is calculations. Some of them come from subtraction. So what will we learn? We will learn that there's no difference between addition and subtraction. There's only addition. And by this, we just simply mean if we had 13 and we subtract 8, we get 5. But really what that is 13 plus a negative 8 equals 5. So there's really no such thing as subtraction. There's only just adding a negative. And that can be helpful to us throughout the sciences. The next thing is that adding measurements with uncertainty, since all measurements have uncertainties, results in sums that also have uncertainties. There are rules for propagating uncertainty in addition. And propagation of uncertainty is what happens when we add numbers of uncertainties. And we'll explain that in the next slide. And lastly, we'll learn that the uncertainty in a sum depends on the least precise number involved. And that means, when we're talking about precise, we mean the decimal place. So, calculations, like the measurements from which they come, they are not exact, they have finite precision, they have a finite number of significant digits, and as scientists, we need to know how to determine what that number of significant digits is. So let's consider an example. We have several students, some of my buddies from when I was in college taking chemistry. We have Mark, Marcus, and Mike, the 3 M's. And they're conducting an experiment, and each of them is massing a component of the experiment, and they want to know the total mass of the experiment. So each of them has a different component. They go off to their balance and get a mass. And this is Mark's and Marcus's and Mike's. So the first thing you might notice is that this one has 5 significant digits, this one has 4, and this one has 5 significant digits. That these measurements have different numbers of significant digits, and more importantly for our purposes here, they have different levels of precision. Since these are measurements, the rightmost digit is always uncertain. So that means this is uncertain, that is uncertain, and that is uncertain. That's where the uncertainty lies. So when we want to find the total mass, we line up these numbers to do addition. This one is uncertain, this one's uncertain, and this one's uncertain. So now when we go through to do the math, our first digit we end up here is 7. Then we have a 9. Then we have a 2. And then we have another 9. And then a 13. And we have our decimal place like so. So we have this final answer. We added up the numbers. We did the math. But the question is, as scientists, what can we say about the total mass? If we look at the uncertain, this 7 we're unsure of. And since this number is 5 and this one's 4, we're sure this is a 5, but we're unsure whether that's a 4. We can't be sure if this 9 is correct. This 2 and this 2 we're sure of, but we're not sure if this is a 4. So that means we are unsure of this 9. So if we think about what this means, we have 353.9297. We are unsure what the tenths is. So how could we possibly talk about the hundredths, the thousandths, or the 10,000ths? We're not sure which one of these it is. So in the end, the number we report as the total mass, a scientist reports this number, 353.9 grams. No. And what we can then see is that this number, which had the least precise decimal place, determines the decimal place of the sum of the final answer. It's determined by the least precise. And now if you look at this number, we know we're sure of if we look at the numbers here, this 3 and this 5 and this 3 we're all sure of. It's this 9 we're unsure of. So in keeping with the definition of a scientific measurement, the rightmost digit is where the uncertainty lies. And now, since this is a calculation not depending on just one measuring instrument, this indicates the decimal place increment of the least precise device. Now, there's a couple words we used in this lesson. Let me define them formally. Propagate. It means to transmit or transmit in a particular direction or through a medium, to spread or promote. So what we have is uncertainty in each of these numbers, and that uncertainty is spread throughout the calculation, yielding a result. That's what it means for something to propagate when we talk about uncertainty. How does that uncertainty carry through a calculation and affect the final result? And of course, the root word is related to propaganda, to spread or transmit throughout. But to propagate uncertainty means, how does that uncertainty carry through a series of calculation? Now, at this point, I'll point out that some of you in your science classes may have come across, you see that I use the word significant digits. You have never heard me use significant figures. That's because it's really actually incorrect. One should never use that. Probably the best definition of significant figures is it's math taking significant digits into account, and that just doesn't need a name. Sometimes people refer to this and they will say it has 5 significant figures. It's actually very common for people to refer to it that way, but it is actually incorrect. And the root of that is that the word figure, to figure, means to calculate or work out arithmetically. So to figure or figuring, a figure is something that's arrived at by calculating. So a measurement isn't really something that would be a figure. Figures, one of a specified number of digits making up a larger number, used to give a rough idea of the order of magnitude. So for example, their market price runs into the 5 figures. So in this sense, what you can see is this word figure is used colloquially. It's used colloquially. It's a colloquial kind of term. And so we really shouldn't use it in our science classes, especially at the AP or the IB level, because it's not actually correct. So to go back to our goals for today in this installment, the uncertainty in a sum depends on the least precise number involved. That means the least precise decimal place. And that constitutes the rules for uncertainty in addition and subtraction, since all there is addition, subtraction's just adding the opposite. That's this installment. In our next installment, we will, of course, take a look at this propagation of uncertainty in calculations for multiplication and division.